All right, number 1 on 6.4 is just a definition. And while we're here, I think it'll be a good time to show you how to rewrite these in log form. So this one is natural log, and there's two different ones that we'll use. Natural log has its base, and then we have just what we call a logarithm. I'm just going to abbreviate with log. That's what we see. It's really logarithm. So what we have right now is y equals ln, which is natural log, of x. You don't see a base down here, but when you're dealing with natural log, the base is always e. It's understood to be an e. Okay. That's always the case with natural log. All right, the way that we rewrite this in exponential form, you take the base, it's going to continue to be your base. You're going to raise it to this power of y, and it's going to be equal to whatever this thing is that we're taking the log of. Okay, so that is e, base e raised to the y power equals x. This is how you rewrite that in exponential form. And they might flip the order. I'm gonna this is arrowhead. They might just write the x on the left, and then is equal to e to the y. It's the same thing. It doesn't matter. All right, but this is the way that you would rewrite that. Now with log, let's just say if we had y equals log of x, and there's no base here, it's understood to be a 10. That's always we count in base 10. Our number system is 10. So the same idea, unless they give you something here, it's understood to be a 10. And when you write this in exponential, again, your base will remain your base. Remember, you have base and exponent. Whatever your base is still your base. So this base is raised to the power of whatever the answer would be, and is equal to this. So we would have 10 raised to the y power equals x. And that's how you rewrite this in exponential. So this first problem is asking this is equal to ln of x if and only if, and we're going to find the exponential form. So that would be e raised to the y equals x. That's what we're looking for. E raised to the y equals x. So that's this one. So they just have it written the other way, but it's the same. It's very important that you understand that natural log has a base of e. When you see ln, it's e, because they do put that 10 up there to kind of trick you. And I don't remember when I was looking through the text that they showed back and forth between natural log and log. Okay, so here we want to find the domain. Okay, so we have restriction. The restriction is whatever you take the log of, so domain has to be log, let's say this domain of log. It could be the same thing for natural log. Whatever you're taking the log of, whatever's here, let's just say x, you take this part, and that has to be greater than 0. You solve that, and that gives you your domain. All right, so in this case, number 2, we are given log, and see, they give us the base this time, base 2, but the 2 does not affect your domain. We're only focused with the x plus 5 part. All right, so when I'm looking for my domain, I'm focusing on x plus 5 has to be greater than 0. When we solve for x, we would subtract 5 from both sides, and that would give us x is greater than -5. All right, so that means if I'm doing a number line, here's -5. I want to be greater than -5, so I'm going all the way this way to positive infinity. And that will allow me to write this then in interval form. So -5 to infinity. Okay, so this would be my domain. -5 to infinity.